Today, we will be discussing the time complexity of the Dijkstra's algorithm. We are considering the algorithm that is given in the textbook Introduction to Algorithms by Corman. If you are unfamiliar with that algorithm, I would recommend that you watch part 2 for a clear understanding of the algorithm. And also, I recommend that you watch part 1 if you do not have any idea of Dijkstra's algorithm. Let us first consider the initialize single source function. This is an initialization procedure in which all the vertices of the graph are initialized, and hence the time complexity of this chord segment is O of V. Next, let's consider the relaxed procedure. As you may see, it does not involve any loops or any recursive function calls, and hence this is a procedure which has constant time complexity of 1. Now let's analyze the Dijkstra's algorithm. As we have already seen, line number 1, which calls the initialize single source function, has a time complexity of V. Line numbers 2 and 3 initialize a set and a queue respectively, and hence they have a constant time complexity of 1. In line number 4, we have a for loop which examines all the vertices of the graph, and in line number 5 we have an insert function that inserts the vertex into a queue, and we know that the insert operation to a queue has a time complexity of 1, and hence the total time complexity of this chord segment is O of V. In line number 6, we have a while loop which runs until the queue is not empty, and we know that there are V vertices which are inserted into the queue, and hence the while loop will run V number of times. In line number 7, we have an extract min function. This function extracts the minimum element from the queue. The extract min function in line number 7 is used to extract the minimum element from the queue. This function performs V number of comparisons during the first iteration of the while loop. It performs V minus 1 number of comparisons in the second iteration of the while loop, V minus 2 in the third iteration, and so on until one comparison in the last iteration of the while loop, and hence the total number of times this function performs comparisons is V square. Line number 8 contains a statement with constant time complexity, and hence this statement will run at most V number of times. Line number 9 contains a for loop which examines the various vertices stored in the adjacency list of the graph, and a vertex is stored in the adjacency list if there is an edge. Hence, the total number of times this for loop runs will be E. The relax function in line number 10 takes constant time to run. Hence, the time complexity of the last two lines will be O of E. Now, summing up the time complexities of the various chord segments, we get the final time complexity as O of V square plus E. Since V square is greater than E, we can say that the final time complexity of Dijkstra's algorithm is O of V square. I hope the analysis is clear enough. Thank you.